That's a baby in the background, everyone.
So cute.
Okay. Oh, all right, here we go. And welcome to the Desk of Ladyada Daycare and LLM.
Thank you. It's me, Lady Ada. I'm here at my desk. We've got a baby man bouncer. So if you wonder what the squeaking is, I'm a little stuffed up, so I've got a little bit more nasally than usual. And today at my desk, we're back doing hardware. Break time's over. And I'm trying out new ways that LLMs can help make hardware easier for me to make, especially since I'm like constantly feeding and caring for now 2 children. So let's go to the computer and see what is on my desk. So this week, I have to find a replacement for the VCNL 4010. This chip has been totally discontinued. If we go to DigiKey and I go to VCNL 4010, it will say, this one, obsolete, no longer manufactured. Please pick the VCNL 4030. Oh, I was going to show. So the LLM I'm using is Claude Code, and the model I'm using is Opus with high effort. Do I need high effort? I don't know. And my prompt is that I want it to help me make the footprint for the VCNL 4030 using the datasheet and creating an EagleCAD library. This takes about 5 minutes, so I'm going to have it run in the background while we talk about stuff and chips and processes. So I was looking at this chip, and one of the things that datasheets do that drives me like a little nuts is when you go to the datasheet and you go to the footprint. First off, this has like a really nutty like pad layout. There's like this weird like nugget here, and this like sticks out like Florida or like a dinosaur. I don't know. And there's like this pad. The footprint isn't so bad in and of itself, but one thing that like again drives me bonkers is they always do edge to edge for the like layout dimensions. So they're like, oh, from the inner edges, it's 1.36, not from center to center, even though CAD software like EagleCAD and I'm pretty sure KiCad and like every other footprint electronics editing software, you do center to center. So you'd say like, oh, from the middle of the pad, it's like the pitch. And so like it says here, there's like 4 millimeters and this is like 0.3 millimeters apart, but it never says the pitch. It just says like the differences between the pads, which is, again, like you can do the math and figure it out. Over here, it does have the pitch, like 105 millimeters, which is a weird number. So what I thought would be nice is that, like, for what I have, like, this isn't too bad of a footprint, to be honest. It's only 8 pads. But I was looking at some chips that, like, can be quite complicated, especially, like, TI power chips, like the pad sizes and dimensions. Would it be cool if we could use an LM to help me with this step? I've used LMs to try to do like schematic layout and board layout, and they can't quite do it yet. Oh. Let's see if this can continue. It's interesting. Every time I have the LLM run, it has like slightly different instructions. It's like, I'm going to use Py to PDF this time. I'm going to let it do it. I should have run dangerously. Yeah, don't go ahead. Let it run and see what comes with it. So over the weekend, I was working on this, and I was like, "Oh, Phil, like Mr. Ladyada here, do you have any suggestions?" He said, "Well, I just got access to Gemini Deep Think, which is like a new model that's specifically for scientific experimentation, and more science and math." And so, okay, now it's actually thinking. Good. I don't know why it doesn't use PDF to text. I have to tell it, like, I might want to have a prompt later that tells it use PDF to text. So we'll see how this goes. Before it took like 5 minutes, but sometimes it takes a longer. And if it does, I can I'll show the final file that it generates, even if it doesn't do it live. And so you threw in, we did the Max 44009, which is a pretty standard light sensor, and it didn't use a very complicated pinout. It uses like a DFN 6-pin with an extended pad in the center, and it was able to do that. I had to try to do the ESP32 P4, and it did an okay job, but it made the pads a little bit too long. And then I think it had to do a couple other things. I think I might throw some cellular modules at it as well. And it wasn't bad, right? Like it didn't totally fail. It made valid EagleCAD files because EagleCAD files are XML. Some people later on social media said they did it with KiCad files and it was able to do that as well. And it just saves you like a step because again, measuring and like calculating and doing the pin mapping, it's easy to check, but it's very annoying to do. So maybe I'll just show, because I had run this earlier to see what came out. So when I ran this, I will say like it's not perfect. Here's some things that did do really well. So the schematic it came up with, one thing I like about the schematic is it did logical organization of pins. So like the I squared C pins are together and the power and ground are over here. What I didn't like is it wasn't smart enough to keep these labels from intersecting. So, I would clean this up by shifting everything over like one. I like to put the I squared C address down here. That's kind of handy. I've done that with some designs. And let me move this over. Boop. And then for the footprint, something that's interesting is that it did get the correct pad size. So the pad size 0.65 by 0.75 millimeters correct. It got the correct pitch, which is like center to center negative 1.005, and then from horizontal it's 105. So half of that is 0.525. So it's center to center for the first two pins. I like to have the center being the center of the pad. But it did think that you needed a center pad because when it looked at the footprint for here, it saw that there's an exposed pad and it was like, oh, this must be mistaken. You need to put a middle pad. But when we did Gemini Deep Think, it didn't add the pad. It was actually smarter. This is like still going. If it doesn't finish in time, that's fine. But it did get like all these pads right, and it got the pin mapping correct. So one thing you can do is like, hand edit it. It, create this ground. I mean, the ground pad's not like the worst thing in the world. Like it'll just be there and it would, there is a ground pad. It just, oddly enough, even though the chip has it, the footprint doesn't, like maybe there's a reason for it, but that's really rare. Usually if there's an exposed pad, it's used for heat sinking or for mechanical centering. So definitely like if you are going to do this as a technique, check the data sheet against the pin numbers, check the footprint. If you have like a rendering of the chip that's available, sometimes manufacturers have that, like do a footprint check. So what I would do here is I would delete this, disconnect, and then, okay, save, and then in the footprint, I would just delete the center pad. Otherwise, it's like, is it faster than doing it by hand? About. It's like if I was doing it, it would take me 15 minutes maybe. Sometimes you can get manufacturer downloaded files available, like DigiKey has them if you go to like EDA download. However, sometimes not available, and not that they're incorrect. Usually the footprint is correct, but the schematic symbol itself is usually not logically organized. It's linearly organized. Again, I prefer logical. But also if there's chips that you're not buying from DigiKey, if you're getting them elsewhere, throw them in, see how it goes. And I did do another experiment, like I said. Let's see if I can find it because I was like, oh, I should make a cutie pie terminal block board. And I was like, okay, I'm going to have Claude. I even kept the logs. I said, Claude Code, can you like design me a terminal BFF? And it didn't do a bad job. This is what it came up with. But like, you see like the labels are like weird and they're like on the wrong, they're like backwards for some reason, which is bizarre. And this is also flipped. It's upside down. I don't know why. So it had a couple difficulties. It did get like, it created like the terminal block footprint, and it used, it got the cutie pie outline. And then when it first created, it was, this was like offset by 1. It wasn't lined up. So I told it how to fix it. It could do this, but I had to go back and forth, and it definitely would have been faster if I had done it by hand. So for schematic and board file creation, and at first it had a mistake where with EagleCAD, there has to be the like footprints and values have to match perfectly, or EagleCAD gets really upset. Like it says like, oh, there's a disconnect between schematic and board, and I had to have the Claude Code instance like fix the X amount typos. And it was able to do that, and it was fine. But the first round did get it correctly. So let me see. Okay, so it's. Oh, let me tell it. Write to vcnl 4030.lbr. Let me see if it can write the file. And then, what other experiments are we doing with hardware and LLMs? I'm doing my.
Yeah, we're doing hardware
feedback
testing.
loop.
A lot of things that if it saved you multiple half an hours per day, that means a ton more time for design. I feel like these are the things that are just in the way of you doing the things that humans want to do, much like the article that's being enjoyed by some, hated by others. There's a long history of women being able to have tools that are at first the source of, hey, you're lazy, you should do it by hand. Some of the comments we got from guys, it's only been guys, has been, you have all the skills, Ladyada. Don't do this. You should use your brain on this. So I don't think you're using your brain on quote on this for things that are just the same thing over and over. It's parts, it's libraries. It seems like you would be able to do something better with that time than just like copy and pasting registers.
One project that I'm going to work on, I started it, is like, so I have my OpenClaw here with like my Raspberry Pi, which is basically running Claude Opus on its own, and I give it an email account, and I'm subscribing to like every chip manufacturer newsletter. So like TI and Maxim and ADI, I know that they're the same company now, and AMS and Vishay, and like I'm actually like going on my way and subscribing to all of them.
You have to go the opposite. Instead of trying to fight the spam, get all the spam to one spot, give it context, and then it gives you something that you're looking for. You have a list of things that you're looking for.
And then I wanted to like give me a report every day, like what are the new chips? Because like I know TI actually has an RSS feed for every chip, but I can't keep track of it. What are the new chips? Are they interesting? Will I like them? Updates, data sheets, like any features, whatever.
Yeah.
Because like, how would you even know if there's a new sensor from Vishay? Like, there's no way to know unless you're like on their newsletter. But the newsletters are like
if the other way
insane.
Is so every week, probably every day, we get requests from whoever sells chips to stop by and talk to us for 2 hours. So that's just not going to happen anymore. We just don't have we don't have time for 2-hour meetings.
Yeah,
we're not going to fly somewhere. We just don't, like, this is the world we live in now, and we're probably going to have to use more smarter tools than what we have now. And this is an attempt. We're experimenting. Is it going to work out? I don't know. No one knows.
Yeah,
but someone has to try.
All right, it's still thinking about creating this file. So that's cool. I can also show some other designs while we wait.
Yeah, let's give it another couple minutes.
Let's give it a couple more minutes because we're doing this anyways. So some designs I did. These are ones that I did by hand because this is before I
you broke the eggs in the cake mix to avoid the 12 slices of shame.
The TMF 8806. So I've stocked the VL53 series, which is ST's time of flight sensors. The TMS series, I think, is from AMS. What I like about these is, first of all, it's always good to have another alternative company because, like, ST, they had their series. They have a lot of different ones. This one, I think, can do up to 10 meters of distance, which is like pretty good. I think that's actually farther than ST's sensors. So I thought that was kind of nice. Also, like, the ST drivers are really complicated, and I think AMS does not have like the firmware blob system that ST came up with. let's see what else. Like I said, the Max 4409. TMAG actually, I don't think is new. I think I just was checking that out. The PMW, this is kind of cool. So somebody was talking to us about like drone sensors, and apparently a lot of drones for dead reckoning, right? Like you use a GPS, maybe they even use like RTK, but if what they do to tell if they're moving over the ground is they have these optical motion sensors. So they're like little cameras with like infinite focus, and they can tell if you've moved up, down, left, right. And I think they're used for like mice, because it's like, that's how you would know like optical mice if it's moved over the surface. So it's getting this sensor as well. This is an SPI sensor, not I2C, but got some mounting holes. Okay, it says it wants to create the library. So far, so good. So PMW, so that's another one we did. Okay, great. So it says it's done.
Yeah, 4 minutes, 45 seconds.
Yeah. So that's how long it took. And then, one thing that's cool is now they have a context map. So you can use about half of its context. So let's go to library and see. So it was like annoyed because I already had the file open with the same name. But this is the new one that it just created. So yeah, it actually did, again, it's not always exactly the same. This time it actually did a better job of having the text not overlap, which is kind of nice. It did have the exposed pad footprint, which I don't like so much. So I'm going to tell it to remove it. So I'm going to say, hey, that EP is actually not used in the footprint. Remove it. And I close the file, so it should be able to edit it. I'll delete this old one. It's going to say, yes, go ahead, edit. It's going to, remove it from the schematic, which I like. And then let's check it out. Yeah, here you go. So, completed footprint. And this is actually exactly how I would have drawn it myself. Like, it really is like exactly my style. Not surprising because it used the library files that were in the directory to kind of get a sense of like, how do I like
this is the thing for the critics that exclusively target you.
Yeah.
Critic.
Dudes.
So our stuff is trained on our stuff.
It's totally trained on our stuff.
The stuff that's out there was trained on our stuff.
Yeah.
It's one of the side effects of doing open source. We've said, go and use it for anything. Our repos and our hardware is in every model.
Yeah.
Sure, it'd be great to do retroactive licensing and say, well, no, I don't want you to use it like that, but that's not how it works with open source.
Yeah.
So we do see that in code, people cut and paste code out of these LLMs. It will have Adafruit stuff in it. Adafruit names, Adafruit. So the hardware fingerprints are in there too. And I think when you're, saying exactly what the prompt should do, it's a partnership between you and a machine, just like auto routing or whatever else you're doing. This is no different.
Yeah, like this just means like now I can, like, of course, look, if there's a downloadable cam file that's known to be good, I'll use it. But when there isn't,
you still have to check it.
Dude, some of these cellular modules, like making the footprint totally sucks. Okay?
And this is day 1 or day 2 of this even being possible with some of these tools. So check back in a year, because you know what? There's 20 years or 15 years of us trying new shit.
Yeah.
And people not liking it. First time you went into AVR Freaks, it's a forum name.
That was a forum.
Dude said, get this girl out of here. They didn't say get this guy out of here. It was, your name's Ladyada, Adafruit. It's clear who you are and what you're doing. And this is what always happens. I've seen it over and over. So good luck, Ladyada. I'm glad you're exploring this and sharing it, because I got an email from someone that said, I'm so glad you're doing this because I'm too scared to put my stuff online because of all these creeps. We got to go take care of baby. Bye.
Show's over.